Okay, so in this video, I'm going to talk about splitting your dataset into training, testing, and validating sets. Whenever you are working with machine learning models or deep learning models, you need to split your data into train and test, which is very common, but basically you need to do three splits. The first one will be training, the second one will be validation, and the third one you can see here is the test data. So the first thing, whenever you are working with these data sets, so what's the purpose of the training data set? So you're using this training data set to teach your model. Basically, your model is learning from this training data set, and after learning, like what happens, the algorithm different models use, these are just adjusting their internal parameters. For example, we may call them as weights to minimize the prediction error, and the size, it's usually 60 to 80% of the data set. So what's the vibe you get? Vibe you get is, hey, I think I get it now. Because you're being trained. You're learning for the exams, you're taking preparation for the exam, you have your notes, you have your lectures, you have your slides, and so many things. So you're being trained right now. You are being taught. So someone is teaching you or you are teaching yourself. So this is your training data. The validation data is, did I actually learn anything from the training? Let's see. So it's like, what's the purpose? It's used during training to tune the model. They're tuning the hyperparameters. There are lots of hyperparameters. It can be number of trees. It can be the learning rate. It can be so many other things depending on the model. So what happens? The model is tested on this data in order to avoid overfitting the training data, right? So the basic standard size is approximately from 10 to 20% of the data. So what vibe do you get? This wasn't on the study guide because you didn't see this data. So this is the unseen data, right? Regarding the test data, this is also unseen data. So the model have no idea about this data. So as a student, now you're going to the exam hall, you're going to attend the exam, right? And in this section, in the validation, you are basically doing your mock exam, the practice exams. So what vibe we're getting from the test data? No more learning. Now show me what you got. So I think this is just an overview, but let's get into much more simple stuffs. So this is the thing that's going to make all the stuffs clear. Suppose you have 100 data points. You as a human being or you as the trainer or teacher, you know all the 100 data points because you're the mastermind. And when you are dealing with the model, you are training the models with 70% or 70 points that you have. And these 30% of the data is unknown to the model. So you're using 10 points for the validation and the remaining 3 points for the testing. So this is how the whole mechanism works in short or in brief. Okay, so when you are working with model, there are two problems. One is underfitting and the other one is overfitting. So what is this underfitting? Underfitting means the model is too simple. It can't capture all the underlying patterns. It can deal with complex patterns. Its performance is very poor in both training and testing data. For example, in terms of regression, the predictions are way off. There are lots of errors. Number of errors is very high. In case of classification, like it's guessing apple as banana, so it has high bias, it's not working properly. So in case of overfitting, the model is too smart. You're just too smart to handle. So the thing is that the model learns too much. It memorizes noises as well in the training data. So it performs badly when you are working with validation or test data. It's like a student who memorized every answer, but in the real exam he's not performing very well, but though because he memorized, but like when he is dealing with complex data, he's not able to understand what's going on. So in case of regression and classification, these are the same problems because of high variance. So this is programming code which I ran. So at first I had imported my libraries, and then I worked with this synthetic data, a dummy data, and then I defined the complexity degrees of my model as 1, 4, and 15. And then I plotted the whole model. So you can see degree 1, degree 4, and degree 15. So this is an underfitting. because you see that the line is linear, but the actual points are like sine curves. Here, the model is perfect because it can, handle the underlying complex pattern very smoothly. This one is overfitting because he understands too much. Like, he's going correctly, but here you can see he's just trying to mix up too much with the data. So he's being just too smart, and you see it's like a spaghetti or noodle or a bit of twist. So this model is having this overfitting problem. So these are like other representations of underfitting, good fitting, and overfitting in terms of regression. And these are in terms of classification. You have like binary classification problems. So you have two classes, the crosses and the balls or circles. You can see that it's a straight line. It doesn't have any idea about what's going on in the data set. And this one has classified, I think it's like around 98% the score will be. And in this case, the model is being just too much smart and trying to deal with each and every complex pattern, which is making the model too much complex. So it is having this problem of overfitting. So these are the basic stuffs about train, test, and validate, and model underfitting and overfitting.